a bunch of maps, a bunch of reuses with a shuffle between them. You write everything to HTML, and then you wait for all of the reuses there to finish before you start the next step. That's actually really painful, because not only are you waiting for everything to finish, after your last task finishes, that's when it's submitted the job back into the cluster. So if you've got a busy cluster, that means you're waiting for however long your job takes to get back to the front of the queue to even start again. Because, no thank you, I'm already running, I'll keep those resources and keep running my job so that instead of having a big delay there, it can just step down to the next piece and start running immediately. That should save us a lot of time. You also can make more complex stacks, right? If you've got some joins and different pieces of processing and then you're joining them together, you can do those with a single DAG and submit it to the test and go run. There's also going to be a test service where the containers are launched ahead of time, so you can get rid of the launch times off of the containers. It won't be required. It'll be an option, though, so that you can get rid of those. Okay, I'm going to get the slides. What else have we done? Because they're building blocks, you can do things like change out the shuffle, right? So we have an in-memory shuffle where you don't even write it to local disk. You just push it immediately to the reduce. That helps reduce the latency even further. We also have some specialized merges where you have a lot of duplicates on the keys, and that lets you run much faster. Okay, so as is there, it's coming, it's in the short term. Part of the work that we're in the middle of doing right now is moving Hive to take advantage of tests. Currently, Hive will submit to tests, but only as an MapReduce. So we needed to extend Hive to work on both MapReduce and tests. But in the longer term, we noticed that there was a lot of potential being left on the floor because Hive has a very generic data model. It's got an object for each row, and then an object for each value, and it uses these object inspectors to look at everything. So by the time you even read it, row into memory and hand it off to the processing engine, you've already done 20 virtual methods before you even get started on actually using the data. So what we want to do is change it around, and a lot of this work is based on the paper on the APB, where if you've got an integer column and a float column and a double column, you have those as arrays of primitives. So your Java type says, okay, I want 1,000 rows, and then you have 1,000 ints in an array, 1,000 doubles in an array, 1,000 floats in an array, and that will let us execute much more quickly. The benefits we see from that are roughly 40x in memory form, because you're getting rid of those virtual dispatches and the stalls on the CPU. So those actually make a huge, huge difference. Of course, it will work well with work, and it will tie the things together. But it requires a complete rewrite. So this is definitely not going to work. A lot of pieces of it will start to work. I love it. That's it. I'm thinking over Hive and renaming it work. I'm not sure what this slide was supposed to show. Oh, this is the call stack. This is the call stack when you're processing your Hive. So that you can see there's all these operators on the stack, and you're unwinding those recursions as you go through. This is a lot of why the vectorization gets this speed up. Okay, so those were our slides. Any questions? in the last part because I realized I was running short on time.
Questions for Adam? Open? Well, maybe I'll ask a question then. So, you know, if Apollo was pretty far along and you guys started this project, why did you not sort of contribute there? Why did you sort of decide to, go with Hive and make it performed?
You want to handle it or
Sure. Well, I'll take the first swing. You can go after it. Well, so for one thing, that's not really something that's open to us, right? It's not. It's owned by Cloudera. It's not something where we can come along and earn parameterized and all that, right? I mean, we work on code that's in Apache that's in a shared third-party place. And we're very happy to collaborate with people there whenever we can, but we're not so excited about collaborating with people in a place where we can't have any kind of say or participation, right? Whereas we get patches at home. The other thing is, we really do believe that Hive is the right thing, right? It's out there, it's used by tens of thousands of people already running on Hadoop. They don't need yet another system. Right? They don't need, here's yet another tool to do a few of the things you want to do on Hadoop. Hive's already there. It's better to evolve something we have than to install something new. The third thing I would say is, in this vision with TES, everything's still controlled by the yarn scheduler. Right? You still have one scheduler running your cluster, allocating things. You don't get in a situation where you're pretending on your nodes for, oh, do I have enough memory for Paula? So I give Paula enough memory to do my previous jobs while I'm running? Do I have to section off stuff in my cluster and give that to the Paula nodes? And then how does that handle the shared, the locality, HDFS stuff? Right? We want a system run by one scheduler so that scheduler understands all the pieces and how to allocate things and have avoid contention.
No, that's most of it. There's also the fact that Hive takes the right approach of it's going to work in big data, right? It's designed to work on data sets that don't fit into RAM and work well at that scale. And I think that's the right approach. If you want a in-memory database, sure, it can answer small queries faster, but once you hit that limit of it no longer fits into memory, then it just stores out the same data. Right? I'd much rather have a way to scale forward rather than be limited by the amount of RAM I've got on my cluster.
Thank you.
No other questions?
Yeah.
For those of us who are users rather than developers, am I going to be able to take my code and get migrate and just compile it, or am I going to start writing it to take it please?
We're being very careful to not break the interfaces, and so you'll just be able to actually use your queries, use your UES, and run in the new model. So you won't have to recode your.
Yeah, and to be really clear, the first set of things I showed have nothing to do with rewriting any kernels, right? So you'll get, much of these benefits for free the next time you upgrade Hive 11. Right? Yeah, down the road to get fullness of vectorization stuff is completely after rewrite. But like Dylan said, we're not going to break the way things are. It's slower.
Because part of what we want to do is embrace the current user base, right? You're trying not to break everything, right? Break the world to make things faster. We're trying to improve things, make things faster, but we of course want to preserve the users of the UES that have been built up over the years to make sure those don't break. Now, especially with the vectorization stuff, we probably will make more performance interfaces for your UES. We want to take advantage of them, but we're going to have backwards compatibility mode where your UES will work in a row by row basis instead of taking brokers and
Last question.
Hi. Regarding the building blocks for days, you mentioned it's map reduce. So there's not a minor mean here, or how does it work?
You would still have a combiner inside. The map reduce is really about having the case where you're sorting out two different keys. So where you currently have a map reduce and there's another map reduce, you can combine the inside map reduce pair into a single.
Thank you so much. Sorry. Next up, we have Storm Yan, where Andy's going to talk about convergence of low latency and big data processing. And he's a very humble guy, so I'll introduce him because he's not going to say anything about himself. He's a distinguished architect at Yahoo, one of the most versatile architects I've seen, moves from projects to projects every month, and literally produced this, which we're actually now having production or coming close to production by working nights and weekends on this. He sits next to me, so I know he doesn't work on this. So please welcome Andy.